Okay, we are going to continue to look at some of the terms under your solution and suspension. So we have concentration. So concentration is the amount of solute dissolved in a given amount of solvent at fixed temperature. Okay, means how much solute can I put inside a given amount of water such that it will dissolve. That will be your concentration. So a concentrated solution will have a large or a high amount of solute dissolved. Okay, a dilute solution will have a low amount of solute dissolved. So common examples will be, for example, if I dissolve 10 grams of salt in 10 cm cube water, and then all your salt can dissolve, that will be a concentrated solution, compared to if I dissolve 1 gram of salt in 10 cm cube of water, that will be a diluted solution. Okay, saturated solution means the maximum amount of solute that can dissolve in a given amount of water. So in 10 cm cube of water, maybe I can dissolve 20 grams of salt, and when I dissolve 20 grams of salt, the salt all 20 grams can still dissolve. That solution will be saturated. If I put in 21 grams, this one last gram or this one additional gram of salt cannot dissolve. Okay. Solubility is the amount of solute that can dissolve in 100 grams of water of solvent at fixed temperature. Okay, so factors affecting solubility, we have the nature of the solvent. So different types of solvent can affect the solubility. Water is the universal solvent, but sometimes we can use alcohol and we can use oil. So for example, salt dissolves very well in water, but it may not dissolve so well in oil. So different types of solvent will affect the solubility. Okay, nature of solute. So sand does not dissolve. Coffee powder dissolves well, but maybe not as well as salt and sugar. Okay, and then the temperature will also affect solubility, and that's why your solubility definition must be at fixed temperature. Okay, so temperature, generally speaking, if I increase the temperature, your solubility will increase. Meaning to say, if I'm trying to make the drink Milo or coffee using coffee powder or Milo powder, if I use room temperature water, your coffee powder do not dissolve so well. But if I increase to a hot water, right, your coffee powder will dissolve better. Okay, so increased temperature will increase solubility. Okay, factors affecting solution formation, factors affecting the rate of dissolving, how fast the solutes dissolve. Okay, first one is pressure. So pressure, think about Coke. Increased pressure, your gas is dissolved faster to form solution. You know, when you open your Coke can, right, and then you hear the fizzy sound, that is when pressure is released and then the gas escape. So what happens is inside the Coke can is actually high pressure. They increase the pressure inside the Coke can so that the gas, which is usually carbon dioxide, can actually dissolve more inside the Coke can. So your drinks can become fizzy. So once you open your can, the drinks start to escape. If you don't drink the Coke for too long, then your Coke will become flat and non-gassy because all the gas escape. Okay, surface area of the solute. So high surface area to volume ratio will increase the rate of solution forming. It will dissolve faster against lumps. So what does this mean? Means if I have lumps of sugar and then I try to dissolve 10 grams of sugar lumps in 10 cm cube water, okay, it may take me 1 day. But if I break these 10 grams of sugar into small powder form, it may just take me half a day. So when I break it down, when I decrease the size, right, what am I doing? I'm increasing the surface area to volume ratio for it to dissolve faster. Okay, stirring effect. This one I'm sure all of you know. If you stir it, it will dissolve faster. If you don't stir it, it will take a longer time. Okay, stirring effect, essentially what it happens is it actually increases the rate of collision of the solutes with the solvent, so solution can form at a faster rate. Okay, and then likewise temperature, increase the rate of solution forming. Same thing, this is because when I increase the temperature, your particles gain kinetic energy. They move faster, so they knock against each other faster, and then they form the solution faster.